Hello everyone. As discussed in the previous videos, the power system comprises of many buses, many generators, many loads. So there is a requirement to compute active power, reactive power, voltage profile in each bus, so that if any load exceeds or if any generator supplies less active or reactive power, then we need to see there should not be any contingency in the system. So to find that, as we discussed, load flow studies are important. So generally the operational features of composite power systems are mainly three things. One is load flow problem, another is optimal load scheduling problem, another is system control problem. This load flow problem is steady state solution of the power system. Generally, magnitude and phase angle of the load buses, reactive power at the generator buses, real and reactive power flow on the transmission line. So these things are the main parameters what we calculate through load flows. Also, using load flows, we can find out increase in the load demand. After the evolution of digital computers, in the olden days we used to use boards, some analog boards, to compute various power system load flow problems. But because of the advancement in the digital computers, these days lot of programs, lot of things have developed. For example, we have open source software EMTP, electromagnetic transient program, similarly ETAP. These softwares, ETAP is commercial software. These softwares are used for load flow analysis. Here in this state of Telangana, here the state electricity board is using SIME power systems. As the power system is having large number of buses, so systematical formulating of the network model of the system is important, so that we can feed the data into the computers, and power is injected from the generator into the buses, and load taps power from the buses. So sometimes there are wire generators to some buses. So when there is a surplus power in one bus, so that can be transmitted via transmission systems to a deficient bus. So the complex power is sum of active power as well as reactive power, and there are three types of buses in the system. One is called PQ bus. So PQ bus, where P and Q means active reactive powers are known, and the unknown parameters are voltages and the delta, that is power angle. And the other bus is called PV bus, or sometimes called generator bus or voltage controlled bus. Here voltage and active power are known, and reactive power and delta, the power angle, are the unknown parameters. And the another important bus is called slack bus, or sometimes it is called swing bus or reference bus, where we'll take one bus as a reference bus with voltage 1 per unit and delta is equal to 0. So that bus is called slack bus. So in the load flow problems, so the all buses except this slack bus are generally PV buses. So there are basically three methods to come to conclusion about the load flow problem. So as we discussed earlier, load flow problems is to compute all the parameters, that is active power, reactive power, voltage and angle, power angle, delta for all buses. So to come to this conclusion, the iterative methods are, because they are all nonlinear equations, nonlinear algebraic equations, to compute the solution, the iterative methods are popular. So first method is Gauss method, and the second method generally people use is Gauss-Seidel method, and another method is Newton-Raphson method. Apart from this thing, there are few more methods like fast decoupled method, then some ANN, artificial neural networks methods are also possible. So in this Gauss iterative method, we need to assume the flat voltage profile for all node voltages except the slack bus, because the slack bus is a reference bus. Then we need to write a program so that we will be discussing the flowchart, or we will be discussing the algorithm. So here we to start with the iteration count k equal to 0 and bus count I equal to 1. Then we need to check for the slack bus. So if it is not a slack bus, then go to next step, or if it is a slack bus, we have to go to step 6 if it is a slack bus. So now we need to calculate the bus voltage Vik plus 1 and the difference in the bus voltage. So we are calculating delta Vik. So that is the previous Vik plus 1 minus Vik. We are calculating this thing. Then we are checking advance the number of the bus count by 1, that is I equal to I plus 1 to evaluate other values Vik plus 1 and delta Vik. Now this process we need to apply to all the buses. So the point 7 will check whether all buses have been taken into account. If yes, then we need to go to step number 8. Otherwise we have to go back to step number 4. Again we need to calculate delta Vik for all the buses. So now we need to determine the largest absolute value of change in voltage delta Va max. If delta Va max is less than the specified tolerance epsilon, evaluate the flows and print the voltages and the line flows. If not, advance the iteration count k equal to k plus 1 and go back to step 3. So like that we will be having number of iterations. As the advancement in the digital computers, the calculation part, iteration part has become easier. Now when the delta Va max is coming under the permissible limit, then the system converges. If delta Va max is beyond the specified tolerance of the epsilon, then we need to calculate for one more iteration. So this is the method called gauss iterative method. So using this one, so we will be calculating all the delta VIs for all the buses, that is bus from 1 to n. Thank you for listening.